Welcome to Episode 27, Configuration Management, Part 3, Evidence, Sampling, and Pitfalls. In this discussion, we focus on proving that configuration control not only exists, but also performs as intended. It is one thing to document change procedures and another to show reliable evidence that each step was followed. Auditors, assessors, and even internal leadership rely on tangible proof that systems remain in a known, approved state. Evidence turns assumptions into verifiable facts. Without it, even the most elegant change policy becomes unenforceable. The ability to prove configuration control protects credibility, maintains compliance, and keeps trust between operational and assurance teams intact. Building on that idea, baseline snapshots with signed hashes serve as the foundation for evidence collection. A baseline snapshot is a point-in-time capture of configuration details such as system settings, code versions, and network parameters. When those snapshots are cryptographically signed, their authenticity and integrity are guaranteed. Imagine capturing a server's configuration before deployment, signing it, and storing the file securely. Later, any future version can be compared to this baseline to reveal unauthorized or unintended changes. These verified snapshots create an anchor of truth, allowing teams to detect drift long after the fact. Properly maintained, they provide auditors with direct proof that the environment matches its approved design. From there, build manifests linked to software versions help connect what was planned to what was built. A manifest lists the components, dependencies, and source repositories that make up a particular build. When each entry points to a specific commit or tag in version control, the manifest becomes a precise record of lineage. Suppose a container image includes libraries from multiple repositories. A build manifest reveals exactly which versions were assembled. This traceability closes the gap between development and deployment. It also makes it possible to identify quickly whether a vulnerable component exists in production. The manifest is thus both a technical roadmap and a key compliance artifact. Continuing this chain of evidence, change tickets should be directly tied to version control commits. Each change request tells the story of what was needed and why, while the commit documents what actually happened. Linking these two artifacts provides both intent and action in one traceable thread. When an auditor reviews a system, they can follow the path from ticket to commit and confirm that approved work matches executed code. For example, ticket number 123 might correspond to a specific configuration update recorded in the repository. This connection prevents silent, undocumented modifications and supports full accountability. It transforms ticketing systems from administrative overhead into genuine control mechanisms. In practice, approval timestamps and reviewer identities add another crucial layer of validation. They demonstrate that someone with appropriate authority evaluated each proposed change at a specific moment in time. These records should include both the decision and the reasoning when possible. Consider a peer review where an engineer approves a pull request. The system records the reviewer's name, date, and comment. Later, that record confirms the approval occurred before deployment, not after. Authentic timestamps prevent post-event manipulation and prove process integrity. In audits or incident reviews, these details often determine whether a control passed or failed. Properly managed, they build lasting confidence in the approval process. Building further, deployment logs and pipeline results serve as live journals of execution. Every automated job that runs, whether it compiles code, applies infrastructure changes, or performs a rollback, produces output. These logs capture start and end times, success or failure messages, and sometimes even environment variables. For example, a continuous integration pipeline might store full transcripts of each build in a central repository. When something goes wrong, engineers can reconstruct the exact sequence of events. For auditors, these logs confirm that required testing and validations occurred before release. Together, deployment evidence and pipeline output make invisible automation transparent and auditable. Extending the evidence model, risk-weighted sampling across environments helps teams verify compliance without reviewing every single change. Not all updates carry the same impact or probability of failure. Sampling allows focus on areas of higher risk, such as external-facing systems or newly automated components. Imagine selecting 10% of routine changes from development environments and 100% of high-risk changes from production. Reviewing those samples reveals whether overall control health remains strong. This approach mirrors statistical quality control, balancing assurance effort with practical capacity. Done properly, sampling delivers meaningful insight without paralyzing operations. From there, unauthorized change detection and automated reporting systems act as early warning sensors. These tools continuously compare running configurations against approved baselines or manifests. When they spot a mismatch, they generate alerts and sometimes even trigger automated rollbacks. Picture a configuration management tool discovering a firewall rule that was added outside the approved process. The system flags the deviation, creates a report, and notifies administrators immediately. Such detection mechanisms prove that oversight remains active between formal reviews. They are the living evidence that configuration control is enforced, not merely written down. In many programs, exception, waiver, and compensation documentation becomes the evidence for decisions made outside normal rules. Exceptions acknowledge that perfect compliance is not always feasible, while waivers authorize deviations for defined reasons. Compensation measures describe additional safeguards used to offset increased risk. For instance, if a legacy system cannot support multi-factor authentication, compensating controls might include tighter monitoring or network isolation. Documenting these decisions ensures transparency and accountability. When auditors review exceptions, they can see that risk was consciously accepted and mitigated rather than ignored. Well-managed exceptions preserve flexibility without eroding control discipline. Building on that, post-implementation reviews capture how each approved change actually performed once released. These reviews examine whether intended outcomes were achieved and whether any unintended effects occurred. For example, a configuration update that improved performance but caused logging gaps would be documented and corrected. Post-implementation evidence shows that lessons are learned, not repeated. It also validates that follow-up actions, such as tuning or rollback, took place. Over time, these reviews evolve from mere reports into a cycle of continuous improvement. They close the loop between planning and real-world operation. Closely related, rollback evidence and root cause documentation prove that control systems respond effectively to failure. When a rollback occurs, capturing before and after states, timestamps, and triggering conditions becomes vital. Suppose a deployment introduced an error that required immediate reversion. Recording exactly how and when rollback happened demonstrates procedural readiness. Root cause analysis then identifies why the issue occurred, preventing recurrence. This evidence shows that resilience is active and functional. A well-documented rollback not only restores service, but also strengthens trust in the overall change management framework. From there, provider inheritance verification ensures that third-party or cloud services uphold the same level of configuration integrity. Many organizations inherit some controls from service providers, such as patching or baseline enforcement. However, inheritance should never be assumed. It must be verified through attestations, shared audit reports, or testing. If a provider claims automatic rollback features, internal teams should confirm they function as described. When gaps appear, compensating procedures can bridge the difference. This verification protects organizations from misplaced trust and ensures end-to-end control across hybrid environments. Finally, understanding common pitfalls and maintaining remediation playbooks keeps configuration management grounded in practice. Frequent failures include weak linkage between tickets and commits, incomplete evidence trails, or missing rollback documentation. A practical playbook lists how to detect and fix each pattern quickly. For example, if approvals lack timestamps, a remediation checklist might require immediate retroactive confirmation and system correction. Learning from these pitfalls builds resilience instead of blame. Over time, these playbooks become teaching tools that preserve institutional memory and raise overall quality. In closing, evidence supports trustworthy changes by proving what works, what failed, and how each decision was made. Configuration management without evidence is simply a belief system, while evidence turns it into an accountable discipline. When baselines are signed, logs preserved, and exceptions documented, confidence replaces assumption. The organization can demonstrate, not just claim, that change processes are consistent, safe, and repeatable. Ultimately, reliable evidence transforms configuration management from a reactive activity into a foundation of operational trust. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.